Hello and welcome back. We are continuing our discussion on pressure and specifically starting to get into the idea of interactions and interactions with fluids. Now, this is a field of study that goes back hundreds of years, back to the 17th century. And during this time, a physicist of the name Pascal started to study hydrostatics. That is to say, fluids that are in equilibrium, they're not moving. And what's important here is that when we look at hydrostatics, we are looking specifically at fluids where the net force is zero. If the net force were not zero, then we would start to get fluid motion and we'd have to deal with hydrodynamics, and we will. But for right now, we're restricting our ideas to hydrostatics. Now, this physicist named Pascal made several observations, and these observations are put into detail with something called Pascal's principle. Pascal's principle states for us essentially the laws of hydrostatics, and it is because of Pascal's principle that we're able to apply it to machines that use hydraulics, and this is one of the most important developments in mechanical technology. The hydraulics allows us to move giant objects, massive objects, with lesser force than the object actually weighs. So it's a powerful technology. So we do seek to understand it. Now, an interesting side effect is because of Pascal's work, we understand pressure a lot better than we understand other physical quantities as they relate to fluids. So it is because of that, when we look at fluids, we often really care about the pressure. So the goals of today, figure out what is this Pascal's principle and specifically how it gives us relationship between forces in different hydraulic systems. When we analyze Pascal's principle, we can write it out as a statement. And what Pascal's principle says is that when we have a container of fluid, whatever that container of fluid is, we will take it to be liquid, but this applies with gases as well. If we have a container of fluid and we apply some pressure to the top, that pressure that we apply to it is transmitted to all of the sides of the container without loss. So this is more scientifically put that when a change in pressure is applied, when a change in pressure is applied to a closed fluid, it is transmitted without loss. Without loss. That's a statement of Pascal's principle. Now, this doesn't give us a lot of information into how to utilize it. So we are going to talk now about an application of this, and we are going to talk specifically about the hydraulic press. Before we jump into the hydraulic press, though, we are going to start with an imaginary container here of fluid. And our imaginary container of fluid is going to be filled and capped on both ends. So I'm going to say that on the right-hand side, we have a cap. On the left-hand side, we have a cap, so that our fluid is completely enclosed. And whatever fluid it is, it could be water, it could be whatever liquid we want to look at, but we are specifically going to look at liquids, meaning that it is not compressible. Now, let me write that out before I forget. We're specifically looking at liquids because liquids are not compressible. And now, this law of Pascal's principle does apply to compressible fluids, but it's just a little bit more complicated. So we're going to keep it as incompressible fluids, liquids. Imagine water. And with these caps, we are going to say that they can move. They won't in this case, but we're going to say that they can move. And when we have these caps that can move, we could imagine putting pressure on one side by applying a force. And what's that going to do? Well, if we apply a force to one side, the other side is going to feel a force and push outwards in response to it. And we want to understand exactly what that force is going to be. So I'm going to label this force left, force right. When we look at these forces, we say, well, Pascal's principle tells us that pressure will be transmitted from one side to the other without loss. What does that mean? That means that the pressure that's exerted on the left will equal the pressure that's exerted on the right. Pressure, of course, we know to be force over area. So if we say force on the left, area on the left, force on the right, area on the right, for our definitions of pressure left and pressure right. If we take the two sides to have equal areas, that is just to say the force on the left is equal to the force on the right. In other words, we can transmit our force over the distance of this enclosed tube. We push on one side, the other side pushes, and in this case where our areas are of equal size, we get the same force. But what if the areas are not the same size? And this is where the mechanical advantage of Pascal's principle becomes apparent. We can create a device called a hydraulic press. And a hydraulic press works off of Pascal's principle. And the idea here is that we can put in an amount of force and get out a different amount of force in return. So we imagine a tube similar to what we've just did, but this time we have a different area on either side. So we have our tube being thin on one side and thick on the other side, both ends capped, filled with some incompressible fluid. And we imagine applying a force on the right, Fr. That's the left-hand side. We imagine applying a force on the left, Fl. And in response, there will be a force felt on the right-hand side because of the transmitted pressure. Now again, Pascal's principle says that the pressure is transmitted without loss. So the pressure on the left must equal the pressure on the right. Well, the pressure on the left is going to be the force on the left over the area on the left. And the pressure on the right, well, that's going to be the force on the right over the area on the right. We solve this. Perhaps we want to know how much force we're getting out of this. So we'll solve it for the force on the right, and the force on the right is going to be equal to the force on the left multiplied by the area on the right over the area on the left. So just doing a little bit of algebra here to solve for the force on the right. And when we look at this, we know, based on this picture, that the area on the right is going to be larger than the area on the left. This is just by the picture, which means that area on the right divided by area on the left is going to be a large number over a small number, making this a value that is always greater than 1. And combining that with our force on the right equation, that is going to tell us that the force on the right is always greater than the force on the left. In this case, the force on the side that is larger is going to be greater than the force on the side that is smaller. So you put in maybe 10 newtons. What do you get on the out? Well, on the outside, you'll get 20 newtons, 30 newtons, some increased amount of force. And this is useful because we can create devices such as a hydraulic jack, where essentially we have one side of our tube that is going to be closed off and small, and the other side we have closed off and large. So we create a U-shaped tube here that is filled with some incompressible fluid, some hydraulic fluid, and we can create a hydraulic lift that allows us, or a hydraulic jack that allows us to put a small force on the out, call this F small, and get a large force on the right hand. I'll call that force large. And these forces are so large that we can create hydraulic jacks that are able to able to lift cars, for example. That's my picture of a car. So we create these hydraulic lifts that can do a great amount of work for us. This is why I said that it creates one of the most important mechanical it led to one of the most important mechanical developments in human history, because it again gives us access to moving large objects utilizing only the forces that a human can produce. We'll do some example problems of this in a future video, but this idea of a hydraulic press, again, very, very important. Very useful for us to be able to solve. Going back to our initial goals, state Pascal's principle. Well, Pascal's principle says pressure is transmitted through a fluid in a closed container. And utilizing this, we can derive a relationship between forces and pressures on either side. And I'll just write it out. We can derive a relationship between either side of like a hydraulic system in which force over area of the pressure is going to be constant. This is by Pascal's principle. So the force over the area is a constant, meaning it's the same value on either side. Okay, so we're going to get into some more discussions of interactions, and in the next video we're actually going to start to look at the question of why do objects float in fluids. This is another hydrostatics question, and then after that we're going to start getting into hydrodynamics, moving fluids. Thank you so much for watching, and if you have any questions, again, please reach out and ask.